This is part 2 for factoring, finding the x-intercepts for polynomials. The first two examples we're going to do in this video are different. You cannot factor these by a common factor since we have a power of 3, power of 2, power of 1, and no power. These numbers do not all have something in common. So we're going to factor these using a different method, and this one's going to be called factoring by grouping. To factor by grouping, you need the numbers from highest power to lowest power, and question 5 is already like that. Then what you do is you just put a parentheses around the first two terms and the second two terms. The parentheses is where the grouping part comes in because parentheses are grouping symbols. So just looking at the first set of parentheses, the x cubed and the 5x squared, you look for what those two things have in common. The x cubed has 3x's, the 5x squared has 2x's, so we can factor out an x squared from that little group there. If you factor out the x squared, then that would leave you with a single x plus 5 in that group. The second group was negative 9x with a negative 45, and those two things have in common a negative 9. If you factor out the negative 9 from the second group, then inside of this parentheses would be an x, and negative 9 times something makes negative 45. To get a negative 45, you would need a positive 5. Negative 9 times 5 gives you negative 45. Factoring by grouping is a cool thing to do because, look, now we got a parentheses and we got two things in common for those parentheses. So we started with a polynomial that looked like it had nothing in common, and by just using some grouping symbols and doing a small set of what's in common, we have an x plus 5 and an x plus 5. Since x squared is multiplying x plus 5 and negative 9 is multiplying x plus 5, these two things have a common factor now. The x plus 5 is now a common factor, and we can pull that off to the side. When you take the common x plus 5 and pull it out to the side, that's going to make you have to open up another set of grouping symbols. Since x plus 5 was multiplying both of these parts, what goes inside of the second grouping symbols is going to be what was in front of the x plus 5. So the x plus 5 was multiplying an x squared, and the x plus 5 was multiplying a minus 9. If you look at the x squared minus 9, we have something squared minus, and then 9 is a perfect square. So this one is a difference of squares. So we can factor that x squared minus 9 to be an x plus 3, x minus 3. And the x plus 5 can just stay an x plus 5. Okay, so we started out with x cubed plus 5x squared minus 9x minus 45. We factored it by doing factoring by grouping, and we got x plus 5, x plus 3, x minus 3. Let's get these and turn them into the zeros. The zeros would be a minus 5, a minus 3, and a positive 3. Let's check that with the graph. And I'm going to graph the original. From that original graph, we got a minus 5 as an x-intercept, we have a minus 3 as an x-intercept, and we have a positive 3, which matches what we got by factoring. Cool. So we didn't make any mistakes. Number 6, let's also try factoring by grouping, which just means let's put some parentheses in front of the first two highest power terms, and let's put some parentheses around the last two terms. And then let's just see if we take out what's in common from these small groups, if things will work out. From the 20x cubed minus 12x squared, we can factor out an x squared. And the 20 and the 12, what do those have in common? 20 can be from a 5, but 5 doesn't fit into 12. 20 can come from 4, and 4 can multiply to make 12, so let's factor out a 4. 4x squared times something. 4x squared times something needs to get us back to the to the 20. That would be a 5x. And 4x squared times something needs to get us back to the negative 12x squared, and that's going to be a negative 3. From the second group, we have a minus 5x and we have a positive 3. Those don't have anything in common, but looking at what we just got by factoring the first term, we have a 5x minus 3. We should probably try to see if we can get this negative 5x plus 3 to turn into this one. So for a negative 5 to turn into a positive 5, we would just need to factor out a negative 1. And for the positive 3 to turn into a negative 3, that negative 1 would also work. So if we just factor out a negative 1 from these two parts, what goes inside of this parentheses would be negative 1 times 5x and negative 1 times negative 3. Now we have a 5x minus 3 in a parentheses and a 5x minus 3 in parentheses. The 5x minus 3 is multiplying 4x squared. The 5x minus 3 is multiplying the negative 1. Since both of these two terms are being multiplied by 5x minus 3, we are now allowed to take that common factor and pull it out in front. 5x minus 3 was multiplying both of those terms, and so 5x minus 3 was multiplying 4x squared, and the 5x minus 3 was multiplying a minus 1. Looking at the 4x squared, 4 is a perfect square, x squared is a perfect square, 1 is a perfect square, so that can be factored farther. Normally we just write an x in front, but since it's supposed to be a 4x squared, we can factor that as a 2 and a 2. If the 2x and the 2x multiply together, it gets you back to the 4x squared. And for the minus 1, we just need a plus 1 and a minus 1. And we'll keep the 5x minus 3. Now let's take those factors and turn them into their x-intercepts by doing 5x minus 3 equals 0. That'll get us an x-intercept at 3/5. And then from these other ones, 2x plus 1 equals 0. That's going to convert to be x equals negative 1/2. And then the other one's just going to give us a positive 1/2. So our solutions are plus and minus 1/2 and 3/5. In each of these examples, we got exactly the right number of roots that matches the highest power of the polynomial. If we had a power of 4, we got 4 different solutions. If we had a power of 3, we got 3 different solutions. There is sometimes whenever you factor it and you don't get that max number of solutions. And when you don't get the max number of solutions, we use the word multiplicity. To show you exactly what I'm talking about, it says the multiplicity of a 0 is the degree of its corresponding linear factor. So that means, well, what if, when we factor this, we don't end up with 3 different factors? When you factor x squared plus 10x plus 25, we get x plus 5, x plus 5. When you solve those, we get 0 and negative 5 as our solutions. And even though our highest power was 3, here we only see 2 solutions. So what that means is this negative 5 that came from those factors, x plus 5 and x plus 5, we'll label the minus 5 as having a multiplicity of 2. That means that the minus 5 is counting as 2 of the factored solutions.